This conference will now be recorded.
Hello everyone, thank you for showing interest in this session on heat exchangers. Today I'd like to discuss some of my experiences in application of smart data analytical solutions for exchanger performance monitoring and troubleshooting, which eventually leads to operational excellence. Before diving into details on analytics and process solution softwares, let's little bit discuss about exchangers. Exchanges have process-wide applications, and the functioning of exchanger can be as simple as cooler or as complicated as plate and fin exchanger, where multiple streams exchange heat simultaneously. Another important aspect of an exchanges which we have to note is that they are part of every important system of a process. So like in compressors, after coolers play an important role to determine overall efficiency and power requirements. Condensers and reboilers play an important role in overall functioning of a distillation columns. In reactor systems, cooling and heating are important aspects, which eventually controls the conversion yields and eventually even the safety of a system. And these are being controlled mainly by exchanges. So overall, if we look, exchanges are process-wide applications. And based upon overall experience, we all know they play an important role in a process industry. Any malfunction of an exchanger or underperformance of an exchanger eventually can impact the overall efficiency of the unit and eventually can lead to a capacity drop or capacity constraint in a unit. This all makes an exchanger a key asset in an operations. And hence, performance monitoring and troubleshooting of exchanger is very, very important. However, it's not a straightforward process because there are multiple operating and design factors which affects the performance of an exchanger. Let's discuss a little bit detail about design factors. Even though exchanger functioning can be simple, but there are several design factors which eventually impacts its performance. Like its shell could be different, you can have different nozzle orientations, baffle cuts, size, spacing, and even tube size, tube pitch will have a big important factors affecting the performance of an exchanger. We also have to understand like process is always dynamic. The feed rate can change, the composition keeps on changing. Also, the weather factors affects cooling water temperature and other parameters, which eventually has a big say in performance of an equipment or an exchanger. Again, whenever we want to measure exchanger performance, we have to find out the optimal performance for the given scenario. And the challenges include measurement and then identifying the deviations from the optimal so that we can understand the extent of deviation, the need for improvement, and the solution required. Fouling adds to another complications to it. The extent, evaluating the extent of fouling is critical, as well as understanding the consequences going forward. All these factors make exchanger performance monitoring and troubleshooting a challenging process. And to address that, we need smart monitoring solution driven by smart analytics and advanced solutions. We have to note that a proactive technical approach generally helps the best because it helps to anticipate the problem at much earlier stage, which gives time to implement solution and basically have desired results at the end of the implementation. And to do so effectively, we need a system in place, a system which is driven by a good approach. Let's look at a DMAC approach, which generally works the best. In DMAC approach, we basically define the problem, measure the performance, analyze the issue, and based upon the analysis, find out the improvement opportunities and implement resulting solutions. And the DMAC process doesn't just stop here. It also keeps on continuing the tracking the process and eventually controlling it on continuous basis so that your equipment or exchanger always operate to the theoretical best. And to do so on continuous basis, we need real-time solution softwares. The real-time solution software, which basically can glean value and sustain performance by continuous tracking and identifying the deviations as early as possible. These solutions helps us to understand the issues accurately, more quickly than manual mode, and devise right applications. To reach to that level, these real-time solutions have to be driven by advanced analytical tools and machine learning techniques which are applicable for this particular solution. Combined application of analytical tools and model is essential to create a valuable and effective solution which provides real-time insights to operations, based on which they can make intelligent decisions, drive changes, and take operations to new level of excellence. All these smart solutions are being driven by technology. The latest industrial revolutions is driving those innovations. Some of these innovations were thought to be very, very difficult to achieve a few years back, are basically changing the face of industry today. And that is true for our process industry also. With the advancement of technology, data mining, data computation, accessing the data, this is not an issue more. The challenge here is basically to identify right data, collect right information, apply right techniques, use right tools and models, basically convert the data and information to right solution, as in converting atom to right molecules. And this needs to be done on live basis, for which we need intelligent software solutions driven by analytics like iSpeed. This real-time solution converts raw data into useful solution on live basis and provide augmented intelligence to manufacturing teams, which helps manufacturing team on real-time basis to drive changes, make difference in the operations, and basically identify deviations, make solutions, and based on that, drive changes which leads to final value capture. And in all this overall process, the most important step is decision excellence engineering step, which basically converts data into augmented intelligence. Based upon industry-wide experience, we all know like applying data, raw data itself has its own limitations, mainly because it's likely to create false positives, which eventually leads to less effective solution. And to avoid that, we need to have an integrated approach combined with domain expertise. Domain expertise is important because there are several aspects in a digital solution which are important to be synced together so as to have an effective solution. It starts with identifying the right objective of the solution and then deciding the right path to be taken forward, which can efficiently convert data into right tools. Application of data science is equally important so as to utilize the right data and apply right techniques, use right models for the solution. Understanding of process helps a lot so that you can improve the accuracy of the application and the implementation rate. Along with this, understanding the software capabilities and integrating with the overall solutions is important so that you get effective solution as well as a cost-effective solution. Along with this, we also had to understand the customization level required because it can change with application, the end user requirement. All these aspects have to work well to have an effective solution, which needs domain expertise, years of applied research, and also good experiences on basically having these solutions implemented. So operations can gain lots through these smart analytical solutions. And to have right solutions, we need to have domain expertise, which can eventually decide the decision excellence engineering process and drive the solutions to a level possible, which can be used by end users in most effective way, driving change and leading to several benefits. These smart analytical solutions are being applied in the industry and is being driving innovations. These are being used by several manufacturers on live basis to glean value. I'd like to discuss a couple of case studies, and based upon those case studies, I would like to explain you the difficulties behind it and how it can be implied in a right way so that it helps the end user in best way possible. Let's start with one case study, which is on smart monitoring and prediction. And this is basically a monitoring system for evaporator fouling. We all know fouling is a critical aspect for any industry, and especially for exchanges, because they not only can drive the exchanger performance, but eventually can impact the overall capacity and reliability of the system. And estimating fouling rate and predicting has been a challenge for a long. However, with advancement of analytics, using right data, applying right techniques and tools, the fouling rate can be predicted accurately and on live basis. Along with that, this analytics can be applied to create right solutions which can provide prescriptive and descriptive advice to operators on real-time basis, which can drive changes and take operations to new level of excellence. So let's look at some of the features of this tool and solution here, basically. So we all know a process experience and applying right analytics helps a lot, basically, to estimate the fouling rate more accurately and predict timeline. Let's look at the dashboard of this and look at some of these features which are being demonstrated here. So if you look at this fouling chart, this tool is basically helping operation to estimate the current fouling rate and also predict the consequences of it going forward. Along with that, it also predicts the boil out, the number of days left for boil out, which means the remaining life of that exchanger or evaporator. This not only helps in identifying the issues, but it also helps in overall planning and scheduling process. This tool doesn't stop here. It also has several other analytical features, which along with prediction and estimation of fouling, helps to do the analytics on live basis. Like this fouling chart here. This chart helps to compare the current performance with any of the previous desired runs to gauge the performance. This helps to identify the deviation and the extent of fouling in more clearer manner. Whenever we are developing such automated solutions, one important aspect of it is to have KPI-based identified solution, which can give an immediate indication to an operator to understand the health of the particular system. And this is being achieved by this KPI indication here. This indicates the health of their particular equipment comparing to the historical benchmarks. And along with that, it indicates whether the health of that exchanger or evaporator is in green zone, yellow zone, or red zone, indicating the health and the importance of that indication right now. This basically helps operator or even operation engineers to understand the health very quickly and need to address any issues on quick basis. Along with this solution also gives another features to monitor the current performance as well as the effectiveness of cleaning. So if you can see here, the past SR cleanliness is compared with the current, and also the current SR cleanliness benchmarking gives you indication how good the cleanliness was last time. So eventually this helps operations to identify the issues and also the focus areas which needs to be looked at so that they can eventually improve the performance of that evaporator. Another important aspect of this tool is that because of application of right analytics tools, a recommendation is being generated, which helps operations to get augmented intelligence on live basis for the current performance of that operator. Eventually, the solution not only helps to identify or estimate the extent of fouling, but also helps to see what are the consequences going forward. It helps to predict run length so that you can have good planning process to identify and extend run lengths. It also helps basically to have uh, it also helps basically to identify the deviations, identify what's happening, whether the current performance is good, identify the KPIs of this, and along with that, have smart recommendations and augmented intelligence provided to operations on real-time basis. This helps to not only understand the extent of fouling, but also to take corrective actions on regular basis without spending too much time and more on accurate basis so that you can have changes applied to the performance, which helps eventually to extend the life, improve the performance, leading to tremendous savings. Now let's look at another case study, and this comes from a ethylene unit. Ethylene unit has several unit operations which eventually impacts the overall performance of the ethylene plant. But in this case, we are just going to concentrate on a feed gas compressor system. This is a system with 5 stages and have aftercoolers and knockout drums after each stage. Before driving into the problem areas of this, let's look at how a PGC compressor affects the overall performance of an ethylene unit. PGC performance can impact a ethylene plant operation in multiple ways. The first and foremost, it can determine the suction pressure, and a good operating PGC system maintains a lower suction pressure, which helps in yield improvements in furnaces. Stage efficiency is an important parameter. Higher the stage efficiency, lower the energy and power requirement. Also, having higher stage efficiency reduces the overall temperatures of the system, and which eventually helps in reducing the fouling rate. And we all know higher fouling rate can limit reliability and run length of a compressor system. Even stage efficiency helps in improving the stage pressure ratios and helping having compressor work better. Degradation of compressor performance can impact in multiple ways and eventually can also lead to plant capacity limitation. And this limitation can come in terms of machine or turbine power limitation, or even sometimes intermediate equipment design limits. So let's look what was happening in the system which we are analyzing. So in this particular PGC system, because of fouling issues, the interstage pressures were running high. And because the interstage pressures were high, the overall plant load was restricted because of these pressures. So to address that, it was envisaged like having more cooling capacity by chilled water application could be possible solution. Yes, that was a good opportunity to do so. But eventually, it was not an easy decision because we have to understand before implementing that how this is going to impact not only the compressor performance, but eventually how it is going to impact the overall plant performance. So the questions were how effective this chilled water would be, how to utilize it in the best way possible. Do we need to have this chilling capacity applied to individual exchangers, or can it be work in combination? What would be the best combination possible, and how it would benefit the overall units? So detailed analytics was necessary to estimate the impact and understand the consequence of overall change. Indeed, it was a challenging problem because of the dynamics involved. So it was not just having the chill water going to any exchanges. It was It was a complicated process because of the overall dynamics, because we have to understand that just adding chilling to any exchanger, obviously it will have big change in that aftercooler performance, which will change the aftercooler outlet temperature and eventually even the composition stream. However, it doesn't stop there. This aftercooler outlet changes impacts the stage performance of the compressor, and also the downstream stages and aftercoolers get impacted due to it. And due to these changes, driving these changes, eventually it will help to reduce the overall temperatures and the volumetric flow rate across the compressors. And once this volumetric flow rate is reduced, the pressures will go down. So once this pressure goes down, we have to estimate how much scope it provides basically to increase the capacity. So all this was a very, very complicated process, and there were several of options which could have been utilized. And so to address that and to find out best solution, advanced analytics in combination of models was applied. This analytical solution utilized several models and including digital twin model, which was fine-tuned to actual operation and was mimicking the ethylene plant performance. Along with that, compressor predictions were incorporated in the analytical solution. Exchanger models were used to estimate this change. So a detailed analysis and combination of these models was run to find out, analyze different solutions and find out the best solutions from it. So several combinations were possible, and this analytic solution was used to determine what would be the best possible solutions and how chilling can be applied in best possible way, and how eventually it lead to possible process improvement and how it will impact overall plant performance in the bottom. So let's look at a couple of best cases which were given by the solution. So in suboptimal case, if we see if the chilling capacity is applied to second stage and third stage, it helps in basically improving the fourth stage and fifth stage performance. And this is envisaged to help increase around 1.3% in the overall feed processing. However, the optimized case, which said like applying the chilling to second stage will be the best option going forward, because this not only helps in improving the fourth stage and fifth stage performance, but it drastically improves the third stage performance, which eventually can lead to increase of around 2% of capacity. So for relatively similar pressure conditions, feed was maximized by improving the chilling impact. Using chilled cooling water in stage 2 of aftercooler rather than in 2 and 3 helped in maximizing the plant loads. An additional feed processing capacity of around 2% was achieved over the limiting case. And in an ethylene unit, 2% is a big number. It eventually led to several $1 million of savings and leading to additional production. So based upon these two examples, we understand like if analytics are applied in right way, it can lead to tremendous value savings. It helps operations in live basis to take intelligent decisions and drive changes which traditionally may not be possible. And it can be done on live basis. It can be done immediately, which drives changes. It takes operations to a new level of excellence. And Ingenro has been implementing this decision insight solutions to several industry overall. And this has delivered value to several manufacturing units across the globe. By applying this advanced analytics and solutions, various benefits can be achieved. And this is not just limited to production increase or efficiency increase. All these solutions and analytics eventually also help to improve the reliability and safety of the process. So all these factors makes digital analytics solutions very, very important aspects going forward. So an asset health is a very, very important aspect for every process industry. It not only helps in lowering the maintenance cost and the operation cost, but it also helps in basically reducing the plant downtime and leading to optimization of overall process. A proven success in keeping these assets healthy using a multifaceted approach comes with domain expertise and application of right analytical solutions. It's important to understand like combining of right and equal tools is very important, along with customizing it with end solution so that it delivers value to end users. If we understand it correctly, digital solutions are driving changes in process industry. It is leading to innovations. It is basically driving process industry to new level of excellence, which could not have been possible with traditional means. The need here is to have right domain expertise. Need is to have right applications, understand with those domain expertise what are the right application tools, models, and eventually creating real-time solutions which can help operations to get augmented intelligence on live basis and basically drive changes which eventually leads to tremendous savings and value capture. I hope this session was helpful to you all. If you have any question, please feel free to reach us at following information. Thank you so much. And thank you AICHE for providing us this opportunity to present this. Thank you.